Alright friends, welcome back to my YouTube channel. We are doing module 3 for our Google Cloud Digital Leader Certification Bootcamp. This module is going to cover storage and a little bit beyond storage as well. Let's look at our agenda. We're going to start with Object Store, that is our cloud storage service. Look at file storage options. Go inside volumes. VMs run, they need volumes, right, for booting, storage, right? So we're going to cover volumes from there. Next, we'll compare NoSQL versus SQL. So this is just for those who are completely new to NoSQL, just getting an exposure to that what is NoSQL. We want to talk about what is the relational database offering in GCP, NoSQL offering in GCP, and then we're going to cover data warehousing, which is BigQuery. We're going to compare how database and data warehouse are different and where, what's the use case between each of them. Then we'll talk about Bigtable, and we'll also compare data lakes with data warehouse for our understanding. PubSub is you could say a messaging service. This acts between two different services as a mediator for transferring the data. And we'll get inside more and understand a little bit more about PubSub. We'll talk about Dataflow. Dataflow is a data transformation service. So in case the data is not in the right format, right, what it is coming and the way you have to consume it. Dataflow helps us to rectify that. At the end, we have Looker, which is a dashboarding service. So quite a lot to cover. Let's get started quickly. So what is an object store? Object store is different from your files storage systems and your volumes, right? So I just want to differentiate in terms of storage types. So we have volume storage, so or block storage, what we call is. When we boot our laptop, right, the operating system has an attached disk. That is the volume, that is the block store that we have. It's one kind of a storage system. Other than that, we have file storage system, which you might see in some corporate offices and certain setups, wherein there is an external drive maintained or a external file server or a NAS drive, what we call is maintained, where data from all the laptops, desktops are backed up over there, or sometimes it's not more than backup, it is a local storage for all the office people to consume from there. Some centralized data is maintained. That's a file storage. So it's neither a block storage or a volume nor a file storage. Neither of it. It's a third type of a storage system. It's called object store because instead of maintaining files in folder-wise file system, it maintains as objects and a key to the object. That is a path, how to retrieve that object. So it's as a key and the object. It's a key value pair system, what we call. Now, why is this so important, right? So you might have counted the 9s which I have written very pathetically on the slide. So it is 11 nines of durability, right? So if you keep like 10,000 files in S3, right, you might lose, one in every million years. That's the kind of probability it has. So with this kind of a probability, right, and the cost which it can offer, it's like a undisputed champion as of now. Besides that, it can scale. Okay, so I can store unlimited data in a single bucket. What is a bucket? Bucket is like a root level folder, right? So how you have C drive in Windows, right? It's a root level folder, and inside that folder you can keep as much as you want. So primary use of it is to keep unstructured data. So data which cannot go to a database service, okay? It could be files, it could be videos, it could be images, it could be logs, right? It could go. Rather, most of the organizations have, about 80 to 90% of the data is unstructured data. So that all can go over here inside the object store. So it is highly scalable, highly durable, right? Availability factor of it is 4 nines. So availability is also pretty good. Use case for data archiving, backup, content distribution, right? All those solutions are a good case with it. We will see this service, how it looks like in the console. All right, so I am inside the storage section, and for those who don't know how to go to storage, can type in storage on the search bar and click on cloud storage over here. Now I already have 2 buckets over here created in past. I'm going to create one more over here just to demonstrate. I can give this a name. So I'll give demo and I'll put some random number because bucket names are unique, not unique to my project, but unique across entire cloud storage ecosystem. We make API calls to it and they all happen over the internet. So the name has to be unique for it to, be connect to it. So that's why you have this as a unique. Now I get a choice in the bucket. I can create multi-regional bucket, dual regional or regional bucket. So it just, improves the availability of it. When I say multi-region, it is going to pan across 3 different regions in the particular geography like US, Europe. If you want to see one more time, you want to see it's US, Asia and Europe. So generally this is useful when your bucket is going to have content which is going to be served to the world. So, if you want to keep data which is being used for a website and stuff like that, right? It's multi-region is a good place to be. Dual region is generally helps you, with getting better durability. So I can select, okay, I want it in US Central one and North Virginia as my 2 locations where data will be kept, maintained at 2 places. This gives me better availability and also in case the entire region fails, I have data in the second region, right? So that's the good part of it. And of course, region is always there, so you can always select a single geographic location and put your bucket over there. Now, next thing, it will give you a choice with storage class. You have standard, nearline, cold line, and archive. We will talk about these a little later, but this is something which you want to keep in mind from your exam perspective. Right? I'm going to create right now as standard, and we'll just create the bucket for now. All right. So there's a lot to understand, but I'm just covering what is important from my exam perspective. Right? So this is my bucket now. I can create a folder. I said that we can't create folders or there are no folders in this. It is a simulation. So when I create a folder, it's actually not going to create one inside the system, but it will put up a slash in front of the object so that, system can understand that a folder has to be simulated over here. Okay, I'll just upload a file. I'll just pick up one of these slides and upload that over here. Right, so upload is successful. All right, I just wanted to show you this. That's it. There's a lot more inside the service, but from our exam perspective, this much is enough to understand. All right, so what I wanted to cover was over here, what are your options in transferring data to GCP, right? So you have cloud storage bucket where you can keep a lot of unstructured data, but how will you move your data to the cloud? What do you see on the screen? Transfer appliance. Now what transfer appliance does is, this will ship you the physical box. Now I've not enabled the API for this, but if I request this, they will send me a physical box at the address which I request for. I can copy all my data inside it, ship it back to them. They will copy it in cloud storage bucket and give it to me. Right? This is an offline transfer mechanism. Now, if I don't want to do it offline, can I do this online? Is there a way to do it online? So the online way is transfer storage service. Again, you have the word transfer in it, but this is called transfer storage. Storage transfer, sorry. So that's the name of it. It's a storage transfer service. Now here you create a transfer job. You provide a source. Source can be S3, Azure Blob Storage. It could be Hadoop distributed file system, POX based file system, or S3 compatible storage. Either of it could be configured as a source, and then you would configure a destination cloud storage bucket to copy the files. This is an online mechanism to transfer your data. Thank you. So we are going to move away from cloud storage now, but before we do that, I just want to fill in with storage class information. Now to reduce your pricing cost, right, per GB, they give you some options. Our standard is the most premium tier, most costliest in terms of per GB cost, where you have no commitment in terms of how long you want to store the data and how frequently you access it. So you can upload a file, download that as many times you want, keep it for as many days you need, and then delete it. Absolutely no commitment over here. Going down from here, you have nearline, where there is a 30 days minimum commitment. Besides that, there is a retrieval fee. So they expect that you are not going to retrieve this data more than once in 30 days. Next is cold line, which is 90 days. Again, here the retrieval fee is there. So you will not retrieve the data more than once in 90 days. Same is for your archival storage. Now, these retrieval fees are levied so that we don't make abusive use of the storage class. So otherwise, I will keep the data in nearline and then download it every day. In that case, the retrieval fee will be so high that it will not only forfeit the cost of standard storage, but also make it more costlier for me. That's how it would work. Right? So you need to select based on both the criterias, whether how long you are going to keep the data and how frequently you want to keep the data. Even if some data is going to stay for a longer duration, let's say it's website content, it's images for website or videos for website, I'm going to keep that for now forever. There is no, thoughts of changing or updating the site at least for next 2 years. Even in that case, I will have to keep it in standard because it is going to be retrieved again and again whenever the website is displayed. Right? So both the criteria are valid. You should think about that and then select the storage class. Alright, so now we are going to talk about Firestore. So Firestore is a network file system wherein you can use NFS protocols to copy and retrieve the data from the centralized storage. Generally useful when I have multiple servers and they need a central location to pull the data from, okay, or write the data to. Either they can write also and they can read also from there. If you implement Kubernetes, right, your Kubernetes nodes would be running across multiple zones for a better availability, and they may need a central storage for them, right, for the containers to fetch the data. In that case, it's a good idea to have Firestore in combination for that kind of an implementation. Right? So let's have a quick view in the console for this. I'm inside the file storage section. Now this works through an instance, so you're going to pay for the whole instance over here. Unlike cloud storage, right, there you would pay per GB wise based on the consumption. Here actually you're paying for the whole VM, and then you're consuming the storage capacity of that volume to be shared across different VMs. That's how the model works. Right? So here you can see the capacity, what you will be paying for, and this is your configuration. This is how it looks like when you start your VM. So you can choose between 1 to 9 TB of storage or 10 to 100 TB based on incrementing with 2.5 TB storage capacity. And this works in a particular network you choose. You have two options of protocol, NFS3 or NFS4 for authentication and copying the files. Right? I'm not going to create this, but this is how the configuration would look like when you create a file server instance. Alright, so now we are going to talk about volumes. So volumes are persistent storage. They get attached to the VM and you can consume it directly with your VM. So they cater as a primary storage when your VMs are working. And there are a few options around it. Let's understand some basics of it and then we'll look at more details in the console also. Alright, so on the whiteboard, what you see, these rectangular blue blocks they are physical servers, representation of physical servers. So this is where the hardware is, right? The physical server is. I may have hundreds of these running together to, serve my customers. Now there are two types of storage you will come across. One storage is a external connected storage. This storage connects over using fiber network, and they are called typically SAN, storage area network, wherein the actual disk is sitting inside a centralized storage system and is exposed to the VM using fiber network. So you get durability in your implementation. Now, what do I mean by that, right? So let's say this physical box fails. Okay, it has a hardware failure. I can start this VM over here. My VM will go in halted state. I can stop it and start it over here. And it can continue because the disk was never inside this particular hardware. This is generally the storage area network service that supports it. And all enterprise implementation have these kind of a storage system. Now, other kind of disk which you will see is what is referred in GCP as local disk. Local disk is a disk that is sitting inside the physical server itself. That means it is sitting over here. And I can consume it with my VM. Now, you can see and understand now that when this box goes away, right, it's powered off, it breaks down, I can get a new VM over here, and this VM will get a new disk. The data in the previous disk will not be accessible. Right? These are referred as local disk. Let's understand a little more about these disk options in the console. All right, so I'm inside the compute section. If you want to come over here, you can just type compute, click on compute engine over here, and this page will load. I'm inside the disk option over here. So, there's a launch menu, and I've come over here in disk. I just want to show the disk options right now. So when I click on create disk, right, I get some options over here to select from. And if I click over here for compare disk, right, you can see the breakup. So standard is a magnetic drive, not very actively consumed in the industry. So you can ignore even from exam perspective that this exists. Three types: balance, SSD, and extreme. Okay, so we had SSDs and we had extreme earlier. Balance was brought in between to give us a little bit of a respite. So not all projects need that kind of a performance of 15,000 IOPS and more, or even 15,000 IOPS, which SSD can provide. So, and between standard, right, and SSD performance difference is also used. So what balance has done is it has given a mediator in between standard and SSD that you can use now. So most of the projects you would land up leveraging on balanced. Things like databases will go on SSD, and really extreme things like SAP HANA will go on extreme disk, right? This would be a breakup of disk of how it would be implemented. These are all persistent disk, and even if the physical server fails, you will not lose your data. They can be snapshotted, they can be backed up also. So this was about a persistent disk. Now let's look at the local disk, how they look like. So if I go to, so they are attached to the VM, they come up with VM. So you have to go to the VM and create a VM to, actually see the local disk option. So let me select this C4A as my option, and here I'll get a choice with local disk if I want to, and I can select the amount of local disk which I want. Again, to bring this point up, that this is a local disk in the sense is, if in case the hypervisor fails, or even when I stop and start the VM, the local disk will be gone. There will be no data. Yes, I'm repeating, even if I stop the VM and start it again, data in the local disk will be lost, right? So be aware of that. It can be only used as a temporary disk, right? That's the only use case of having a local disk. All right, so just wanted to cover about different disk from the console as well. All right, so we're going to understand now difference between SQL and NoSQL. Now the SQL, right, is always been there in the industry since years, and most of the transactions which we do, right, are all running out of SQL databases. NoSQL is relatively a newer concept and has recently gained a lot of importance in the industry. The major difference between the two, the schema and relational data is fixed. So it's like a table kind of a structure, and multiple tables can be joined together to make use of it. Versus NoSQL database is schemaless. The schema is free, structure is not very hard, it's dynamic and can be changed. You can have more attributes, less attributes over a period of time, and the structure is very flexible, unlike the relational database. Let's understand this a little more from the whiteboard. Alright, so in my whiteboard you can see there are two different tables which I have created, and first table represents user information, it's starting with user ID. Second table refers order information, that is starting with order ID, and the number of columns which are created are rigid for both of them. Now, since order ID is a common factor between the two tables, using SQL in a SQL database, you could join them together and pull records out. I could have third table pertaining to items where you would have details of items. That could be a separate table that I would maintain. And I could connect all three of them when required using a SQL join. That is the core of relational database. Data can pan across different tables and they can be joined and queried upon. That is why we call the relation capability between them. Now, in a no relational database, the data is kept in a different format. It's in a JSON structure. Now, in this case, the only unique item in it is one thing which you select as your primary key. Let's say, for example, I select user ID is my primary key. Rest, all of them are what we call as attributes. These attributes can differ in every record we add. So in next record, I may not have name available. I may just put maybe mobile number, or I may put address over there. Rest of them are not compulsory to be maintained. So this is what we say is the schema is flexible. Okay, I can just check the key and the value whenever I need for any kind of records in it. Right? That's how it would look like. Other thing which I want to point out is the way relational database scales and the way no relational database scales. Generally speaking, in a relational database, if you try to implement something like MySQL, right, you would land up, creating a MySQL server by yourself. And when it comes to expanding, you can increase the memory and the CPU and the storage kind of with it, and it can scale this way. Now, it gives you an option to create something called failover replicas, which will have, copy of the same, record in it in case one goes, other one can serve. So there are limitations of how, these can scale. Versus NoSQL database are more easier to be implemented as a horizontally scalable solution. In the sense is I can have very simply a multi-node environment and can keep adding more nodes for it to scale. A very common implementation of it is MongoDB. Now, this is one kind of a relational database which you are looking at, where the data is used with key value pair kind of information. There are other implementations also of NoSQL databases. One of them very commonly seen is Redis. It's an in-memory cache, and it is for caching, but again, it falls under NoSQL database solutions. All right, let's get back inside these slides now. All right, so the thing which I want to point out the use case around it. Generally, your transactions, right, are all based out of relational database. Whereas NoSQL database have a bigger use of real-time analytics, social media for caching, as I said, Redis, Memcache, IoT. So these are some cases where NoSQL databases are better fit for it. Example of relational databases: MySQL, PostgreSQL, Oracle, Microsoft SQL Server. NoSQL, we have MongoDB, Cassandra, Redis, DynamoDB, Firebase. These are all NoSQL databases. Here you have joins and relationships, strong support for relationship between tables. Here there is no support for joins. It is a denormalized database. That means whatever you want, you have to add it inside the same row itself, you cannot join two tables in that kind of, you can't build relationships. It's rigid, the structure is rigid, the data has to be planned and designed much more in advance. This is flexible. You can, as I said, the primary key has to be unique. That's it. Rest all the attributes can keep changing around it. So that's unique about the NoSQL database. All right, so this was just to bring this insight how SQL and NoSQL are different from each other. Thank you for watching it. All right, so if you're going to now cover Cloud SQL. So Cloud SQL is a managed solution for SQL database in GCP. Now, if you want a SQL database without Cloud SQL, you would have to go to a virtual machine instance, create it, load some operating system, install whatever database you want, engine you want to put MySQL, PostgreSQL, Microsoft SQL, you have to install it over there and use it. So instead of you doing that, you troubleshooting, updating, patching, all that effort you put in, they give you this as a managed service. Let's have a look at it from the console. All right, so I'm inside the Cloud SQL service. So if you want to go over here, you can just click on SQL, you will reach over here. You have three engine options: MySQL, PostgreSQL, and Microsoft SQL. You also get PostgreSQL from RDBMS, which can scale beyond typical PostgreSQL which they offer over here. Now, what else is different? The managed service, you don't have to get inside the patching, updates, right? For scaling, it is very easy. You can choose to, go with multi-instance implementation, multi-zone high availability, and you can choose which zones you want to do with it, right? And then you can have, kind of a failover instance pre-created. You can very easily create read replicas. So, the effort required to create and manage, right? The heavy lifting of administration and, upkeep of it is taken care, automated backups, right? So you don't need to worry about backups. It's already there inside built in, just restore when required. So all that is, typically built in when you do managed services of Cloud SQL. That's it about it. I think that's just enough information required for our certification. Thank you. All right, so here we are talking about Cloud Spanner. It's a fully managed, horizontally scalable relational database solution. Now, this is like if you're migrating from on-premise to cloud, there you're using Oracle and you don't want to buy Oracle license in GCP, you have an alternative. You could shift to Cloud Spanner. It's a global database, so I can have nodes running across different regions, across I can have one node in Iowa, other one in maybe Salt Lake, and one in Dallas, and still they can replicate the data among themselves with strong consistency. So it's a globally available relational database solution, but it's a proprietary solution from GCP. Right? So moment you feel that your application is going to scale beyond typical relational databases like MySQL and PostgreSQL running on Cloud SQL, right, and it's stuck to one particular region for availability. If you need a multi-region enterprise level database that can pan across multiple regions, then the answer would be Cloud Spanner. Thank you. All right, so let's compare Cloud SQL with Cloud Spanner. Cloud SQL is a managed relational database. Cloud Spanner is globally managed distributed relational database, you could say. Cloud SQL supports open source and Microsoft SQL. So you have MySQL, PostgreSQL, Microsoft SQL support on it. Spanner uses Google's own proprietary SQL database solution. Cloud SQL can scale vertically. You can increase the RAM, CPU for it. Spanner has a multi-node architecture. It will keep adding nodes and it can go over multiple regions also. Cloud SQL offers strong consistency within a single instance. Spanner offers strong consistency across globally distributed nodes, right? So globally consistent, you could say. This is asynchronous across replication with read replicas. This is synchronous with global replication and automated failover. Use case, traditional applications, OLTP, workloads, websites, small and medium business databases can simply work with it. Spanner, massive scale application, global transaction, financial services, gaming. So the problem statement which you're trying to solve is also much more bigger with it. Okay? This is just to bring in the difference between the two solutions. Thank you. Firestore, right? So it's a NoSQL fully scalable solution, and it's a serverless implementation. Now, how serverless is different from managed services? In managed services, generally we get the opportunity to decide the size of the instance. I can say, okay, memory will be XYZ, CPU will be this much, and then I configure the service. Patching, updates is relatively easy, right? So the housekeeping and all is much more simpler than you doing things by yourself. In serverless, right, we are absolutely just creating the table over here in Firestore and consuming that table. Rest everything is taken care by the cloud provider. So no configuration of CPU, memory, right? Everything else is taken care by the cloud provider. It's a serverless implementation for us. Common use case, it's good for mobile and web application development. Right? So it's a good use case around using the Firestore service. Again, remind you, there are no scope of creating multiple tables and joins with it. That's going to be a constraint with it. Thank you. Before we go ahead and understand BigQuery, I wanted to compare database with data warehouse. Purpose of database is to record transactions. Transactions with respect to any kind of transactional workload like e-commerce, banking, versus data warehouse, where historical transactions are maintained and then we build reports out of those transactions. Databases are very fast for inserts. Based on the database engine you select and sizing of it, you can handle anywhere between hundreds to millions of insert requests per second with a relational database. Versus data warehouse, they are quick for reading. So if I have like a TB of data in BigQuery, I can still query on top of it within a couple of minutes time. That's the speed which BigQuery will offer me. So at one end, I have writing speed, that is my database. At the other end, I have reading speed, which is data warehouse. And it is meant for that kind of a requirement. Some examples of database in GCP, Cloud SQL, Cloud Spanner, Firestore. Data warehouse, we have BigQuery. BigQuery. BigQuery is a fully managed data warehousing solutions which GCP offers. It's really, really fast. Can handle petabyte scale data and do real-time analytics on top of it. Let's look at BigQuery in the console for a minute. All right, so we are at the BigQuery interface. I have already kept the query ready, and in this query, it's going to look for the term Google inside Wikipedia benchmark database. And when we run this, it's going to process about 5.17 GB of data. So it's going to scan through that to fetch us the result. Okay. Now, if you look at the job job information, then you will see, it has taken 0 seconds. It's showing 0 seconds because I tested the query a few minutes back before I recorded the video, and it is taking it right now from the cache. Having said that, the first job also got completed within 5 seconds. And even if I do this for 5 TB of data, it will get over in a couple of minutes. I just wanted to prove that speed is really, really excellent when it comes to BigQuery. What else BigQuery is very good at is it can also do your machine learning. So that's another capability that's built in inside BigQuery. You can use SQL dialect to execute queries and do machine learning in BigQuery itself. That's it about BigQuery. Thank you. So next we have Bigtable. Bigtable is a horizontally scalable, massive database which can really work at a very low latency. Generally used for real-time analytics. Uh, it could be stock data, it could be IoT sensor data, where you want a capability of recording or capturing records at a very low latency and representing it in a live dashboard. This is where Bigtable shines. It can scale to hundreds of nodes parallelly to process the information. There are very limited use cases which you will find Bigtable implemented. So generally, when you need really fast analytics, okay, and that also you want to record the items very quickly, maybe millions of requests are coming in per second, you want to record all those, and then see live those in a dashboard, right? So until you don't have that kind of a request to handle, right, Bigtable will not be an ideal solution. So again, it's a NoSQL database solution, which can be used for analytics. Low latency inserts is what it can very well and very effectively handle for you, going into almost 10,000 requests per node, and then you can scale with number of nodes you need. So that's how it grows. All right. Before moving forward, I just wanted to give you all some information on what is data lake and how data lake is different from data warehouse. Now, data lake is typically, send everything over here at one place, kind of a thing. You have structured data, we have unstructured data. The idea behind data lake is we keep one common storage in the organization where each and every data is maintained. So it's like, data could be in the form of anything. It could be images, videos, it could be CSV files, logs. You still maintain everything at one place. And then from this, if you need something consumable, right? So like maybe you need some historic data for doing some analytics, you could take from data lake and send it to data warehouse and use it over there. So data warehouse has always been a structured place where you have a fixed schema, and whenever you insert the data, it has to be in that right format so that it could be stored inside the data warehouse. Now data lake generally is one of the most reliable storage solution you need. So mostly in the cloud you use object store for it, and it is also comparatively cheaper than structured solutions generally. So most commonly you would see cloud storage in Google, S3 in AWS, Azure Data Lake being used as a data lake solution to maintain this kind of a data. I just wanted to give you the idea of what data lake is. Thank you. Next, we're going to talk about PubSub. PubSub is a messaging service. It allows asynchronous communication between two services. Let me explain this in the whiteboard. How does this work? Now, what you're seeing is an architecture wherein I have a load balancer over here. Okay, and I have 3 web servers and I have 3 worker machines. Now, let's say I have a distributed application wherein request goes to the web server and worker server needs to process it. Now, if I do one-to-one mapping, then if the web server is down, worker is of no use, and if the worker is down, web server is going to not be able to respond correctly to the request. Now, there could be one way to solve this kind of a problem, but one way of doing it is via a queuing system like PubSub. I can ask the web server to publish a message to the topic whenever they get a request. So they are all sending a request to this web topic over here, saying that this is the task to be completed. In turn, this message can be delivered to these workers, or workers can actually poll to the queue and get the amount of requests that are to be processed. Now, with this kind of an implementation, right, I have a breakup of my web servers and my workers. And in case one of the workers go down, other worker can come up, pull from the queue and continue serving. So that basically breaks my architecture and makes it asynchronous. So PubSub is basically a queuing system wherein you can send a message and you can receive messages. So some service in your architecture will send a message to the PubSub and some other service could receive the message from it. So it's for asynchronous communication. I think that's more than enough to understand from this particular exam perspective. Thank you. Next, we are going to cover Dataflow service. Now, Dataflow is a fully managed streaming and batch data processing service. It is useful for real-time analytics and it uses Apache Beam under the hood to help the processing. Developers can leverage on Java and Python languages to build their pipelines. So, what problem is Dataflow trying to solve for us? Let's say, for example, that I'm getting some messages in my PubSub, for example, and these messages come in across the globe from some IoT sensors. Now, all that data that comes in, I might want to write that out to cloud storage bucket or BigQuery or Bigtable or any of these services. But I want to unify the timestamp. So maybe it's coming in from the device time, which is not standard UTC time. Every device is in different country and they might have different time zones. So maybe I check the device ID and I convert that time into UTC and then write it off to cloud storage bucket. Any kind of data transformation requirement I could do. I could do aggregation with data in between. So any kind of data manipulation which I need, my Dataflow can help me do that. That's the idea behind this service. It works with both batch and streaming, leverages on open source platform Apache Beam for its implementation. So Dataflow is nothing but a managed Apache Beam solution for us. Not managed, I would say serverless implementation of Apache Beam for us. So we don't have to configure anything, just create pipelines and Dataflow will take care of scaling, provisioning, patching, updates, everything. We just consume the pipeline. That's it. So that's a bit about Dataflow service. Next, you're going to talk about database migration service. Now, many a times you are moving to the cloud and you have your database running in some database solution. You want to seamlessly migrate without having a downtime or restricting your downtime to the minimalistic. DMS is for that, database migration service is meant for that. It helps you move the data from one database solution to the other database solution, reduces manual intervention, automates synchronization, and you can even do online as well as offline migrations with it. I think that's enough for us to understand about this service. That is database migration service. Thank you. All right, so we are at the end of the module and we are looking at Looker now. So Looker is not a storage system. It is a dashboarding system, right? So you have data in the cloud, you're going to store the data in cloud storage, you're going to keep it in BigQuery, you're going to keep it in Bigtable. But at the end, right, you want to come up with dashboards, you want to come up with reports, you want to have, visual presentation of your data, right? So very first thing, Looker can be integrated to get data from various different sources. So data could be lying in CSV files inside your cloud storage to BigQuery, to Bigtable, to Cloud SQL, different types of sources you can use to inject data inside Looker, and then you can come up with the dashboards with Looker, right? And these dashboards can be collaborated with the team, and it could also, they could also play around with dashboard depending upon, if you give the rights to underlying storage like BigQuery, they could even, filter things on the dashboard itself. So that's the beauty of Looker service. I think that's more than enough to understand from our exam perspective with Looker. All right, so at the end, I just want to compare different storage options that we have discussed in this module. We started with cloud storage. Cloud storage again is an object store, right? It is useful for backup, unstructured data, files, logs, everything that needs to be saved, stored, but cannot go to database can always come to cloud storage. Firestore is a file sharing system, NFS file shares, for multiple applications to read write together to the same storage. That's your Firestore service as a managed solution in GCP. Block storage, you have SSD, balance disk, hyper disk, all of them are attached volumes for VMs. Based on the performance requirement, you could select those. Cloud SQL. Cloud SQL relational database that is managed MySQL, PostgreSQL and Microsoft SQL Server. That's what it's the offering over here. Spanner is distributed database from Google and it's a proprietary solution but can scale beyond typical MySQL implementations. It can be a global relational database solution. BigQuery, data warehousing solution for analytics and handling petabyte scale data for analytics and machine learning. Bigtable, it is NoSQL wide column database. It's low latency and high throughput. Generally it is for time-driven, time series data, you could say, where you need very, very low latency and very frequent write and throughput management. So like when you're looking for anywhere starting from minimum 1 TB of data and handling about tens and thousands of requests per second, right? Then you should be, looking at Bigtable. AlloyDB is a managed Postgres compatible enterprise level database offered via AlloyDB. Firestore NoSQL document database, that's majorly for your web and mobile backend applications. Thank you. Alright, so it's time for our Q&A. What is the difference between standard and cold line storage? Option A, cold line storage is for data for which a slow transfer rate is acceptable. Option B, standard and cold line storage have different durability guarantees. Option C, standard and cold line storage have different APIs. Option D, cold line storage is for infrequent accessed data. So comparison between standard and cold line. So if you remember, we had discussed this when we discussed storage. Your answer is cold line storage is for infrequent accessed data. Question 2. Your organization wants to migrate its data management solution to Google Cloud because it needs to dynamically scale up or down and to run transactional SQL queries against historical data at scale. Which Google Cloud product or service should organization use? So using SQL queries, you want to dynamically scale up down and you are doing historical data at scale. So queries against historical data at scale. So this is nothing but your analytics and we have BigQuery for this. Question 3. Your organization is migrating to Google Cloud. As a part of that effort, it needs to move terabytes of data from on-premise file server to cloud storage. Your organization wants the migration process to be automated and to be managed by Google. Your organization has a dedicated interconnection connection that it wants to use. Which Google Cloud product or feature should your organization use? Option A, storage transfer service. Option B, migrate for Anthos. Option C, BigQuery data transfer service. Option D, transfer appliance. Now there are two options which kind of align to the question. You have storage transfer service and transfer appliance. Now transfer appliance is for offline transfer and storage transfer is for online transfer. So in this case, Your answer is storage transfer service because they already have a dedicated interconnection which they want to use. Now, this is a dedicated fiber connection. What is interconnect? We will talk about it when we go to storage. When we go to networking. But to answer this in short, you are looking at online transfer, that is your storage transfer service. Your organization needs to analyze data in order to get to gather insights into its daily operations. You only want to pay for data you store and queries you perform. Which Google Cloud product should your organization choose for its data analytic warehouse? Data analytics warehouse is BigQuery, there is no brainer. And in BigQuery, you only pay for your storage and for the queries you run. So your answer is BigQuery. Your organization is developing an application that will manage payments and online banking accounts located around the world. The most critical requirement for your database is that each transaction is handled consistently. Your organization anticipates almost unlimited growth in the amount of data stored. Which Google Cloud product should your organization choose? A. Cloud SQL, B. Cloud storage, C. Firestore, D. Cloud Spanner. Are you looking for a relational database because it's transaction and you want it to grow global, so it can scale globally? And this again is a no-brainer. This is your Cloud Spanner service. Your organization wants an economical solution to store data such as files, graphical images, videos to access and share them securely. Which cloud product or service should your organization use? I think this is also a no-brainer. By now you all should know this is going to be your cloud storage. Your organization is moving an application to Google Cloud. As a part of that effort, it needs to migrate application working database from another cloud provider to Cloud SQL. The database is running on MySQL engine. The migration must cause minimal disruption to users, and data must be secured while in transit. Which should your organization use? Basically, which service your organization should use? A. BigQuery data transfer service, B. SQL batch insert, C. Database migration service, D. Cloud Composer. I think again this is no brainer. You are using database migration service in this. Which Google Cloud service or feature lets you build machine learning models using standard SQL and data in data warehouse? You have only one data warehousing solution, and that's BigQuery, and it has BigQuery ML. We spoke about this. So this is also very straightforward and simple. This is the last question in this module. Your organization needs to build streaming data pipelines. You don't want to manage individual servers that you to do the data processing in the pipelines. Instead, you want to manage service that will automatically scale with the amount of data to be processed. Which Google Cloud product or feature should your organization choose? A. PubSub, B. Dataflow, C. Data Catalog, D. Data Prep by Terrafactor. Right answer is Dataflow. Your organization is developing an application that will capture a large amount of data from millions of different sensors spread all around the world. The organization needs a database that is suitable for worldwide high-speed data storage and a large amount of data. Which Google Cloud product should your organization choose? Firestore, Cloud Data Fusion, Cloud SQL, and Cloud Bigtable. Well, you are looking for a global database for IoT sensor data, which is for high-speed data storage. This points out to our Bigtable service. So there are some terms which were there in the sample questions. I just wanted to cover those terms just to make sure that you all are at least familiar with these. Now, data prep by artifact. This particular service is for data transformation. Okay? It gives you a UI for correcting your data. So whenever you are moving your data from one kind of a system to another system, like you have that as a coming in from your IoT sensors, or it could be stock market ticker data, archival data of previous sales, and you want to load it in some data warehouse, but the format in which you want it is not there and you want to fix it. Now, of course, your Dataflow can do that, but Dataflow requires you to write the code in either Python or Java. So there are a lot of templates which help you with it. If you want a visual way of doing it, where you can just see the structure of your data and go and you can select, and it will automatically suggest you what kind of kind of changes you should be doing in your data. So it's based out of machine learning for data, fixing your data, I could say. So that's your data prep by artifact. So that is one service which I wanted to talk about. Now, other service, data catalog. So the cataloging service helps you with metadata of your data. So basically, wherever you have movement of data, you want to put some cataloging on it to track the lineage, to understand what kind of modification happened, where did the data come from. That is the data catalog service. Now, the third service, what you see is cloud data fusion. Now, data fusion is again helps you with data pipelines. So again, this is very similar to your Dataflow, but this is completely building a pipeline. The data prep service is only for your transformation of data. It doesn't create pipeline. Data fusion will help you, give you a UI basically to decide where you want to, what will be the source of your data, what transformation you want to do, and where the data will finally go, the sync of the data. And it's fully based out of UI. You can create streaming as well as batch pipelines from data fusion. That's a UI way of building and managing your pipelines. You could compare this to, again, with Dataflow, but this time it's a full pipeline versus data prep, which is just correction of data or rectification of data using UI. Right? So that's the difference between the three services. Last term, BigQuery transfer. We saw this in a couple of questions. What is this? So this service basically helps you load data in BigQuery. So if you have data in CSV file, Parquet, or some structured format which you want to load the data inside it, or you want to schedule ongoing loading of jobs for data inside BigQuery, you can do that using the BigQuery data transfer service. Thank you. All right, friends. Thank you for completing module 3 with me. Please do subscribe, like, share with your friends. Put in comments how you feel about the modules, about the training. If you have any questions, feel free to ask. I would love to answer those. Try to do it as soon as possible. Thank you so much for doing module 3 with me. See you in module 4. Thank you.